So I told you that we can prepare aldehyde from primary alcohol, okay? Or we can prepare ketone from secondary alcohol, or also I told you that we can go reverse. Like we can reduce our aldehyde into primary alcohol by using a reducing agent, okay? Or you can say इसी तरह से we can convert ketone into the secondary alcohol by the reducing agent that is LiAlH4. So, and second thing is that I told you if you are going to have oxidation of primary alcohol by using KMnO4 or K2Cr2O7 potassium dichromate. So if the condition is written that this is heat under reflux, okay, this is heat under reflux, so the product would be carboxylic acid. The product would be carboxylic acid, okay. And if the condition is written that it's heat and distilled, so your product would be only aldehyde. It cannot be further oxidized. That's the difference between heat under reflux and heat and distilled, okay. Or I told you the two reducing agents that was LiAlH4 in dry ether. Since lithium is included in this, so you are not supposed to put it in water. So that's why we are going to use a solvent that is ether, okay, to prevent the reaction of lithium with water basically. Or we have another reducing agent that is NaBH4, sodium borohydride. It's a mild reducing agent. It's a mild reducing agent, right? Okay. So today we are going to discuss identification of carbonyl group. Identification of carbonyl group. So identification of carbonyl group. Identification of carbonyl group. Carbonyl group तो दोनों में होता है ना? You can see that carbonyl group is also present in aldehyde and it's also present in a ketone. So the carbonyl group is this. Carbonyl group is this basically. This is the carbonyl group. Whether the carbonyl group is from aldehyde, whether the carbonyl group is from ketone. So we have to identify this. You know, we can use 2,4-DNPH to identify this. Okay, to identify this. So let's suppose this is the test tube, okay, in which the sample is there. This is the test tube, okay. So I'm going to add, I'm going to add 2,4-DNPH. I'm going to add 2,4-DNPH. बोले तो डाइनाइट्रो डाइनाइट्रोफिनाइल हाइड्रोजीन डाइनाइट्रोफिनाइल हाइड्रोजीन. After adding 2,4-DNPH, if orange precipitates are observed, if orange PPT is observed, okay, if orange PPT is observed, so means that carbonyl group is confirmed. means that carbonyl group is confirmed. Means that carbonyl group is confirmed basically, right? Carbonyl group is confirmed. उसके बाद you have to identify कि what is this ketone or is this your aldehyde? वो तो बात की बात है. First of all, you have to identify the presence of the carbonyl group by adding 2,4-D-NPH. So after the addition of 2,4-D-NPH, that is 2,4-dinitrophenylhydrazine, if you can see the orange PPT, so we can say the carbonyl group is there. And then furthermore, we would be identifying aldehydes and ketones. So we have some reagents which can identify aldehyde and ketone easily. So now the thing is, how can how can we differentiate how can we differentiate between aldehyde and ketone? This is the main question. How can we differentiate between aldehyde and ketone? ये बिल्कुल ऐसा ही है when you used to discuss how can we differentiate between alkane and alkene. So उसमें क्या करते थे? You used to add bromine water. So in the presence of bromine, like in the presence of alkene, क्या होता था? Bromine decolorize होता था, right? So and in the presence of alkane, there is no change. So the same goes with this. We would be adding some reagents into aldehydes and ketones. Okay. So then we would see के what would be an observation. तो वो कौन कौन से reagents हैं याद रखिएगा. We have yeah, like you can say Fehling solution and Tollens reagent. Fehling solution. Okay. We have Fehling solutions and Tollens reagent. We have Fehling solution and we have Tollens reagent. सही है जी. तो ये दो चीजें हमारे पास होंगी. So first of all, remember कि I need to explain that what is Fehling solution. Fehling solution. Fehling solution. So basically, Fehling solution is also known as Benedict solution. Fehling solution is also known as Benedict solution. Benedict solution. Benedict solution. उसके बाद कि how can we prepare the Fehling solution? So remember, it's a solution of copper 2 plus ions. It's a solution of copper 2 plus ions. Okay. Uh, copper 2 plus ions. It's a blue solution. So alkaline solution of copper 2 plus. Alkaline solution of copper 2 plus. Okay. And the color of the solution is blue basically. Color of the solution is blue. Okay. Color of the solution is blue. It can only react with aldehyde. It can only react with aldehyde can only react with aldehyde. ये याद रखना सिर्फ aldehyde से react करेगा. You know, this is an oxidizing agent. ये क्या है? It's an oxidizing agent. It's an oxidizing agent. Okay, ये oxidizing agent है, and you know that only aldehydes can be oxidized. Only aldehydes can be oxidized. Okay, so it doesn't react with the ketone. It doesn't react with the ketone. वो अलग बात है कि it's a mild reducing agent, oxidizing agent. Mild means a weak oxidizing agent. Okay. So so what would be the product? What would be the product? So remember, okay, this is this is the aldehyde CH3 C double bond O then H. It's going to react with copper 2 plus ion, aqueous ion. We have added some alkali in it. Okay. तो याद रखना कि when your aldehyde is going to be oxidized, what you would be getting, obviously you would be getting the salt. वैसे तो aldehyde can be oxidized into carboxylic acid. Since you have added an alkali, that is OH negative ion, so OH negative ion would be taking its H ion, H positive ion, and it would be making the salt, that is this. Or another product would be Cu2O, that is cuprous oxide, copper 1 oxide, and the water is released. This is solid. This is solid. This is solid. This is the red PPT. This is the red PPT. Due to copper 1. Due to copper 1. It's a red PPT due to copper 1. Okay. तो जब आपको ब्लू के रेड पीपीटी नजर आ जाए इसका मतलब क्या है कि एल्डिहाइड इज कंफर्म्ड. यू आर सपोज्ड टू बैलेंस दिस इक्वेशन. You are supposed to balance this equation, so it would be 2 copper and 2 copper. Okay, it's 5 and it's 3. Okay, okay, ji. So it's balanced. So this is the equation that you need to write when the examiner would be asking. But remember, in short, Fehling solution can only react with aldehyde, and it would be giving you some observation that is blue solution to the red PPT. So if this is happened, so you can say your aldehyde is confirmed. If this is happened, so you can say your aldehyde is confirmed. Okay, बिल्कुल simple है. So finally, what you got? Finally, what you got, copper 2 plus is changed into copper plus 2 changes into copper plus 1. Copper plus 2 changes into copper plus 1. Okay, it's the loss of electron. Nah, sorry, gain of electron. So I can say na that this is reduced. Something which is reduced, something which reduces itself is an oxidizing agent. सही है जी, oxidizing agent. तभी तो इसने एल्डिहाइड को ऑक्सीडाइज कर दिया इनटू कार्बोक्सिलिक एसिड. So you must know this. Okay, or I can say this is the salt. This is the salt. Okay, चलें जी. Next thing is that I'm going to use Tollens reagent. Tollens reagent. What is Tollens reagent? What is Tollens reagent? Uh, and what is the formula for this Tollens reagent? Let me tell you something about that. That it's you can say it's silver ammonical solution of silver nitrate. It's ammonical solution of silver nitrate. Okay, whose formula is this, right? The name of this is silver 1, silver 1 diamine ion. And you know it's colorless. Initial color इसका क्या है? No color. While the color solution was blue initially. Okay, the color of the Fehling solution was blue initially, so it turned into the red precipitates. But now the tolerance reagent is colorless. But now the tolerance reagent is colorless. Okay, so if the tolerance reagent is colorless, so we can say that okay, it would be, and also it's an oxidizing agent. Again, I would say it's a mild it's a mild oxidizing agent, just like Fehling solution. It's a mild oxidizing agent. It's a color, can only react with aldehyde. Can only react with aldehyde. Okay, तो ये इसके कुछ मेन इंपॉर्टेंट पॉइंट्स हैं. सेट हो गया जी. ओके, अच्छा जी, आइए जरा. We have some equations. First of all, this is the same aldehyde. Okay. So again, this is an oxidizing agent. Product would be the same. Okay. जगह नहीं है, थोड़ा इसको मैं पीछे कर देता हूँ. This is water. This is water. Okay. Sure जी. Then I'm going to balance this equation. 2 and 2. Okay. This is silver 0, silver PPT, or I can say the silver mirror is formed. अगर ऐसा हो गया, अगर ऐसा हो गया, so it's mean that aldehyde is confirmed. Aldehyde is confirmed. Okay. So what you saw in this equation, silver plus, इसमें change हो गया, silver zero में. So again, it's reduction. If this is reduction, so what is this? It's an oxidizing agent. Okay. Failing solution and tolerance reagent cannot react with ketone. Failing solution, tolerance reagent. ये मेन पॉइंट है इसका. सेट हो गया, चलें जी. Then we have nucleophilic addition reaction. Nucleophilic addition reaction. अब मुझे न्यूक्लियोफाइल के बारे में बताने की जरूरत तो है नहीं. I told you in alkene and also in alcohols what are electrophiles and nucleophiles. You know, nucleophile is going to, you can say, see uh, any any negative center. You know, nucleophile positive center. Nucleophile is having a negative charge. It's a nucleus lover, and nucleus has positive charge. When someone is going to do attraction with the positive charge, so it must have a negative charge itself. That's the reason nucleophile is negative. Since I told you that in carbonyl compounds, the carbon is having a positive charge, due to the presence of highly electronegative element that is oxygen basically, so oxygen would be having partial negative charge, which makes it the carbon that is partial positive. So that's the reason the nucleophile can attack easily on this. The nucleophile can attack easily on this. So that's the reason. So that's the reason K. It would be giving us nucleophilic addition reaction. Okay. Then also the mechanism is required in this as we did in alkene. That was electrophilic addition reaction. So it was electrophilic addition and this is nucleophilic addition. Okay. So first of all, we are going to do this reaction in which I'm going to react aldehyde with the cyanide ions basically. So remember, first of all, I'm going to write the general equation. I'm going to write the overall equation. So you can see ये मेरा aldehyde है. इसने क्या किया, HCN से रिएक्शन किया. In the presence of NaCN and KCN, and this is in ethanol. As a solvent लिया मैंने. So ये मेरी प्रोडक्ट बन गई है. ये मेरी प्रोडक्ट बन गई है. ओके. तो याद रखिएगा, दिस इज द रिएजेंट, दिस इज द सॉल्वेंट, और जो ये है ये कैटलिस्ट है। सही है ना? अब हाउ इट हैपेंड, वी नीड टू डू अ मैकेनिज्म। ये कैसे हुआ? वी नीड टू डू अ मैकेनिज्म। तो आई एम गोइंग टू डू दिस मैकेनिज्म। तो सबसे पहले आई एम गोइंग टू टेक एल्डिहाइड, दैट इज दिस।
Sir, can you go a little bit up? I just want to see the reaction. Nucleophilic addition reaction.
Yes. And also, the temperature should be 10 to 20 degrees Celsius.
Okay, you can continue, sir. Thank you.
ये टेम्परेचर होना चाहिए। चलें जी। It has partial negative, partial positive charge. Okay. अब होगा ये कि we have a cyanide ion having a negative charge. ये अटैक करेगा कार्बन पर। Okay. So obviously this bond is going to break down. This is the pi bond, and then I would be writing this CH3C. This is your carbon. Oxygen is having a negative charge. The cyanide is attached, and this is the hydrogen. Okay. Oxygen is having a lone pair of electron. ये कौन सा lone pair है? ये वाला electron है basically. ये वाला electron है, इसको मैं यूं बना रहा हूँ ताकि make sure कि you must know कि what is this. So ये वो electron है that was over there. Okay. So ultimately now it has a negative charge. Now it has a negative charge, so it would be reacting with what? Say this. It would be reacting with, this is your partial positive. Okay. Then you can see that finally it's attached. ये OH बन गया। सही है। Cyanohydrin is formed. Cyanohydrin is formed. What is this? Its name is 2-hydroxy propane nitrile. सही है। This is the nucleophilic addition reaction. You can do this reaction with ketone as well. Same goes with ketone.
Sir, wait, let me take a screenshot of the whole mechanism.
Okay.
Thank you.
Okay जी, कीटोन के साथ जरा आप लोग ट्राई करो, फिर मैं बताता हूँ। कीटोन इज दिस।
No, no, sir, wait, let me take 1 minute.
ओके ओके, एक मिनट।
Yes, okay, thank you.
ओके, अच्छा जी। कीटोन के साथ सेम रिएक्शन, पार्शियल नेगेटिव पार्शियल पॉजिटिव, reacting with cyanide, that is nitrile. देखिएगा जरा, this is CH3. बिल्कुल सेम सेम कर रहा हूँ जो वैसे था, कोई फर्क नहीं है दोनों में। ओके, बिल्कुल वही प्रोडक्ट बनी है, 100% सेम, नो डिफरेंस। एंड आई टोल्ड यू iodoform test. I told you iodoform test, but I'm telling you again that what is iodoform test? Okay, iodoform. Iodoform test में, you know, iodoform test will be only giving the positive test for the methyl ketone. methyl ketone ये होता है, this is the methyl ketone. This is your methyl ketone. If this group is present, so iodoform would give you a positive result. Otherwise, no. Otherwise, no. Which reagent and conditions I'm supposed to use in iodoform test? So the reagent is alkaline. So the reagent is alkaline aqueous iodine. Okay, that is I2 with NaOH. And then ultimately heat, उसको फिर हीट करो आप। ओके, चलें। तो let's suppose this is the sample. This is the sample, that is this. आयोडीन से करवाया इसका रिएक्शन, so you know what you would be getting, this product or this product. ये आपका सॉलिड है, यही तो होता है येलो पीपीटी। इट्स येलो पीपीटी। अगर येलो पीपीटी इज ऑब्जर्व, सो मीन्स दैट दिस इज कंफर्म्ड, मीन्स दैट दिस इज कंफर्म्ड। और अगर येलो पीपीटी इज नॉट ऑब्जर्व्ड, सो मीन्स दिस इज एब्सेंट। Okay, so this is a test for the presence of CH3C double bond O. This is the test for the presence of CH3C double bond O. CH3C double bond O. CH3C double bond O. Remember, okay. Let's suppose I'm going to take this product. I'm going to take this product और सब कुछ सेम, सब कुछ ये देखो जरा, सब कुछ same. Everything is same. So what can I do for this? If everything is same, so what can I do for this? Okay. If everything is same, तो फिर इसमें डिफरेंस क्या होगा इसकी और इसकी प्रोडक्ट में? तो याद रखना हमारे पास बनेगा CH3C double bond O and O negative. The rest of the product would remain the same. Rest of the products would remain the same. So if the yellow PPT is observed, so means that CH3C double bond O group is confirmed. So this is the iodoform test. And in alcohol, I told you that it's going to give the positive result for the secondary alcohol as well. Okay. For the secondary alcohol as well. So, अच्छा जी. Okay. Acha. Then you will see in some questions that he would be asking for this equation. Like you told that while we are going to identify the carbonyl compound, so we are going to add 2,4-D and pH in this. And if orange precipitates are observed, so means that carbonyl group is confirmed. Okay, so write down the overall equation in which you can see the orange precipitate that 2,4-D NPH is going to react with the carbonyl group. So remember, first of all, you need to know that what's the structure of 2,4-D NPH. What's the structure for 2,4-D NPH? So I'm going to write this equation. You can see this. This is any of the carbonyl group. This is any of the carbonyl group, that is this, okay? It may be aldehyde, it may be ketone, and I'm going to draw the structure for 2,4-D NPH. Acha, that is H, then N, then H, then this bond, okay? Or then we have another nitrogen. This is your hydrogen. It's connected with the ring. It's connected with the ring, that is this. Okay. And this is NO2 or this is NO2 as well.
Sir, which
Dinitro.
equation is this? For what equation is this?
Basically, when we have added 2,4-D and pH in the sample may contain aldehyde and ketone. So I told you that if your observation is orange PPT, so I can say that carbonyl is confirmed. So like orange PPT means what? So we have to justify that what is orange precipitate. So that's why I'm going to tell you, okay, the carbonyl group is going to react with 2,4-DNPH. This is the structure for 2, 4-DNPH. Dinitro, 2-nitro, dinitro. Phenyl is the name of the ring. This is phenyl, and this is your hydrazine. This is your hydrazine, that is N, 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 N. So they are going to react together, okay? Or okay, uh, this is going to be removed. This is going to be removed. That is water. Water is released. and rest of the compound would be attached. कैसे? Just like that. C double bond O. O तो चला गया. So remaining thing would be attached. Remaining species would be attached just like that. This is N H. This was orange PPT. This was orange PPT. Okay. तो ये equation जो है, I would be asking. Like he would be asking the product. He would be giving you the reactant basically. You're not supposed to memorize the structure for the 2,4-D and pH. No. Okay. You're not supposed to memorize the structure of 2,4-D and pH. That's all about the carbonyl compounds. Okay.